Hemos elegido para la primera charla de hoy a una persona muy especial, a un emprendedor que está desarrollando una solución muy única. ¿Te imaginas que con proteína de soja conseguimos crear proteína de cerdo? Esto es algo que ya se está haciendo. Nos va a hablar el fundador de Moolec Science sobre cómo, a través de edición genética, agricultura molecular, cómo podemos transformar un vegetal en unas propiedades que sean totalmente la de un animal, a nivel salud, a nivel propiedad. Y para ello, pues quiero invitar, I will switch to English, today will be a bit of a mix. I want to invite to the stage with me Henk Hoogenkamp, the founder of Moolec Science. Welcome, and thank you very much.
Buen día. Oh, Cata. Bea, sorry. Buen día. My Spanish is very terrible, so we keep it in English. My name is Henk Hoogenkamp. I'm very happy to talk to you today. A bit nervous, but most importantly, excited. Today, it's all about trying to show you what we're trying to do as the wider industry of molecular farming. I'll show you some examples of what we're trying to do. I will try to take you along to a journey, and I ask you to keep your mind open for this journey, right? To keep your personal assumptions aside and see what this technology can actually do. So, see it this way. Oh, it's not working, sorry. We have many problems in our world, but we don't agree on the problems. We don't agree on the solutions. We don't agree on the priorities of these solutions. And this makes it very difficult to develop technologies, extremely difficult. But the thing is, I think, looking at all these complexities in the world, I think we can agree on a couple things, despite that we don't agree on the problems, is we are facing a lot of challenges in our food production today. The European Union has recognized that we will suffer major crop loss, or let's say loss of croplands in the European Union. We will not be able to grow the wheat and the corn where we're currently growing these. You know, even if that's being recognized right now. Could you imagine the breadbasket of France disappearing further northern and northern and northern? What's going to happen? You know, it's not just the bread, it's not just the corn, but it's also the animals that we feed these products with. So I think we can agree on that. We need to do something about addressing these challenges, major challenges. The thing is also, I think we need to valorize more the side streams. People talk about valorization. People talk about side streams, but we never talk about what's the definition of a side stream. You know, when we make a technology, we always say, let's put these side streams to good use. But our technology has grown in such a way that actually the side streams is what pays for the crop. It's been so skewed that we need these side streams to pay for the main crop that we're feeding to humans. So why can't we redefine what side streams mean? You know, it's not only doomsday, because I believe in humanity, and we've always been able to make new technological advancements in the face of adversity, but we still need to understand the science, how we could use the science to shepherd these changes. So I would say, you know, today we stand on the brink of another technological frontier. And this, you know, this frontier is very exciting, and we're going to be discussing these today. Or I mean, hopefully some of these. But it's really important to recognize that these technologies still rely on the input of traditional agriculture. We still need crops to grow the crops on actual land, and to put these in, or fractionate them, or process them, and put these into these technologies. So you know, it's not a bad thing, but we still need input. So we need farmers. That's the most important thing. We also need to recognize that many of these products are only made possible by the animal industry. You know, if you make a good plant-based product, you waste a lot of material that has to be fed to some places, or fed to some animals. So the cost of our current products that we have in the market today that we deem sustainable, they're actually co-funded by animal agriculture. So the question is, if we're trying to remove animals from the equation, how come we're only developing more and more complex technologies? The technologies are becoming more complex, and they're becoming more expensive. So how does that work? You know, can we step back and see the entire picture? That we can't just develop and say, oh, I have this new pea protein on the market, and yeah, it's going to make the best product. It doesn't work that way, because that 1 kilo of pea protein is funded by the 5 kilos of starches and fibers that come along with it. And basically, yes, it ends up in noodles, but most of it ends up as animal feed. So, you know, we need to have that discussion, that open discussion. So I'd like to introduce you the concept of molecular farming. Molecular farming challenges the very core of agriculture. I mean, it doesn't challenge it, it actually supplements it. You know, with molecular farming, we have the possibility to change farming at its very core. You know, we can change the plants themselves to do what we need them to. But more importantly, we can change the plants to make sure that they fit our current processing capacities. It doesn't make sense to start building, you know, fields full of stainless steel bioreactors if we can't grow the crops, or if we even can't afford them, let alone if there's enough steel. So we need to make sure that the technologies we develop are compatible with the current infrastructure. That's so important to realize, because that means there's no upfront investment into these new technologies. So right now, there are companies using this type of technology to make dairy proteins in beans. They're using it to make enzymes in seeds. They're also using it to make growth factors for culture meat. And even certain vaccines can be produced in plants now. So, you know, we're already doing this. We're doing this already. So how can we use this philosophy? How can I put this philosophy in your head and think about crops in a different way, as mini bioreactors that only feed off the sun, off the water, and off the land that we currently use? And currently at Moolec Science, what we're focusing on is meat proteins. So what we're doing is we're making taking these seeds, and we're having them make the meat protein of choice. So I would say, I think, you know, they always say a picture speaks 1,000 words. And now, and this is, you know, I'm trying to show you the picture that actually shows our results. Back in 2020, when we started Moolec Science together with Gaston and Martine, we thought, okay, you know, how can we change the plants at this fundamental level? And we started talking to ag tech giants, and they said, if you could get 1% of animal protein in your bean, you'd be lucky. You'd be super lucky. But fast forward 3 years, we've been able to reach a certain level where we can reach 26.6% of the soluble protein in the bean is our animal protein. That means about 5 to 10% of the bean weight is expected to be our animal protein. If you translate it to acreage or hectares, that means we can grow anywhere from 100 to 400 kilos of animal protein on land per hectare. That's mind-blowing. Because now, if you look at it, how much land do we need to feed these animals to make these very same proteins? Also, what happens here, you can see here in this picture, is we've actually seen a color change due to the expression of these proteins. So the bean is actually, it has a different function. It has a specific function due to the protein that we're expressing. And depending on the protein that you're expressing, you could change the function of the bean. So that means in the future, when we start doing more and more of these projects, we can select the protein and match it with the function that we want for that bean. It could be nutrition, it could be texture, it could be taste, it could be color, it could be anything you think of, right? Lastly, it's also worth noting that this isn't just about increasing the yields on the land itself, but about changing the crop functionality. So right now, these traits that we're making, they're not coupled to the use of pesticides yet. We can, like in traditional, but we can also decouple them. So I want to challenge you in thinking, if we have a genetically modified plant that we grow in an organic way, is it still organic? Because the organic does not reference the plant. It references how we grow things. So would this be acceptable? I would say so. So our journey doesn't stop with proteins alone. We also have targeted the fat fraction. So what we've done here, or what has been done actually, is a genetic code was inserted for a very specific enzyme. And this enzyme turns an inflammatory omega-6 fatty acid, which is linoleic acid, it turns it into gamma-linoleic acid. And this gamma-linoleic acid is anti-inflammatory. It's the right omega-6, it's the healthy omega-6. And you say, okay, what is the market from gamma-linoleic acid? It's pretty big. It's about 1 billion. But it's now serviced by crops which are very small and very difficult to grow on scale. So it's not used a lot because it's expensive. Basically, in this safflower plant, that's our host. Basically, we've turned an oil, using this technology, we've turned an oil that's 1 to 2 euros a kilo, maybe 3 euros a kilo, to 30 euros a kilo. Just by changing and adding an enzyme. So could you imagine the added value you can add just by changing things? So I'd like to take you as well to imagine if we take this philosophy further. So we're talking about proteins, we're talking about fats, we're talking about all these these things that we usually talk about. We say this is where we get this functional ingredient from this part, and this is where we get this crop where we get this functional ingredient from. How about you turn it around? How about you make your crop where you can get all your functional ingredients from the same bit of land? Imagine that we can optimize the land. Every bit of land that we use, every drop of water, every unit of energy is all used optimally to make the things that you need to make, the functional ingredients that you need to do. And this is where the byproduct valorization comes in. This means that it's no longer a byproduct, but it's maybe the product that you're saying, I want to have this specific component in this fraction, which I can remove and gain value from. But that means that you're valorizing the byproduct. You're not making it too expensive to valorize. Many of the fibers and the starches are too low value to valorize, and then they're sent off into feed because we cannot extract the right components. So if you make it more valuable, if you make your byproduct or your side stream more valuable, you can actually justify the input that you make into removing all the valuable components. So it is not only about starches, or not only about proteins or fats, but also about very specific components, bioactives, certain peptides, maybe certain sweeteners. We're not working on that, but we invite you to think about it, So over the course of human history, I think the thing that's really changed, that's really guarantees change, is increased efficiency. We can put all the ideologies on the table, but the only thing that really changes things in the world is higher efficiency. It's changing the value for shareholders, for the stakeholders, not shareholders, but the stakeholders. So, if the farmer can make more money, it means it's probably something efficient, and vice versa. If it's more efficient, the farmer can make more money. So, I think it's important right now to recognize that molecular farming is not just our product, but it's a vision. It's a vision where we don't change. We don't change what we eat. Actually, we are changing a bit what we eat, but we don't change what we eat or how we grow it. It's about how do we shape what we're growing, and more importantly, how do we share this? I think that's really important because we need to be sharing our food, our protein sources, globally. Let me see. The last point I'd like to make is, I think even though this is a GMO technology, I think it's a vision we can all unite behind. There's no real good evidence that the actual genetic modification of a crop is creating harm. People are talking about GM in a way now with the glyphosate issue in the European Union because it's coupled to glyphosate, but not because of the genetic changes you're making to the crop. We're taking a known protein and a known crop and combining them. And in this case, the math is not 1 + 1 is 2. No, 1 + 1 is still 1. Because they're two known quantities. Nothing changes, just the way how we make them. So, see molecular farming as a way to scale up precision fermentation. see molecular farming as a way to make culture meat a reality, because we can grow things at the cost of the beans. It's mind-boggling to think where the possibilities can end. So I'd like to ask you to put your preconceptions aside and at least recognize that molecular farming, is not a product itself, but it's a way that we can change the entire ecosystem, how we feed the world. Thank you for your attention.
Thank you very much, Henk. It was a very bright presentation to start with, and thank you for sharing your vision. I am sure you will be one of those food change makers, and this will be a very disruptive technology that will change things. So congratulations.
Thank you.
Thank you, Henk.